is kicked, it will accelerate, or increase in speed. The velocity of the ball is the speed of it in the direction it is traveling. Newton's first law says that the ball will stay at rest until acted on by an outside force. The ball stays at rest until Logan kicks it. Newton's second law is force equals mass times acceleration. Two balls of different masses that are kicked with the same force will have a different acceleration. Newton's third law states that the force that we kick the ball with is also exerted back onto Logan's foot. So the force felt by the basketball will be the same force felt by Logan's foot.
Yeah, that actually kind of hurt.
Told you. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity. The more mass it has, the more momentum it will have, and this is why Jack was more affected by the ball with more mass. Take it like a man, Jack.
We boil water and then we're going to add it to the Tupperware container and cap it. Hot water in a closed container creates a heightened pressure because of Boyle's law. Pressure is a continuous physical force exerted on or against an object by something in contact with it. We can see the pressure increasing because the cap rises.
It's shaking.
In this example, we squeeze a water bottle, which decreases the volume and increases the pressure, which will, according to Charles's law, pop, just like it just did.
This is an example of diffraction because as the light passes through the tiny slits of the pencil lead, it spreads out in multiple directions. And you can see the different little dots on the wall. Demonstrated here is total internal reflection. As the light passes through the water, it reflects off of the sides of the stream, and that's why it goes with the stream, much like a fiber optic cable.
Refraction is the fact or phenomenon of light, radio waves, etc. being deflected and passing obliquely through the interface between one medium and another, or through a medium of varying density. So when Logan pours the water in the cup, that quarter underneath the cup will appear to disappear. It's unable to be seen. And when he pours it in the straw cup, the straw will appear to have broken.
It does.
For our watermelon experiment, we mixed salt and water together to form an electrolyte. We then used a negatively charged copper strip and a positively charged zinc strip and shoved these into our watermelon. We then laid this watermelon with strips in it into the electrolyte. The negatively charged electrons from the copper flow out into the electrolyte and then go into the zinc strip. Then the watermelon completes the circuit, and so we have an electric charge or a current flowing through. We can tell this because we used that current reader and we plugged that in, and it said that we do have a flow of electrons through the wire. And then we checked the voltage with the voltage reader, and voltage is pretty much the potential energy of electricity. It shows how much electricity is released at a time through the circuit, and this is called watts. And it said we had voltage. While the electrical potential difference established between the two terminals encourages the movement of charge, it is resistance that discourages it. The electrical resistance of the electrolyte is a measure of the difficulty to pass an electrical current through it. The rate at which charge flows from the copper strip to the zinc is the result of the combined effect of these two quantities.
Where's going?
Our current. Dear God.
I know.